Hey, I apologize for that. My computer just shut off without saying anything. So, okay, we were at our labels. When this is true, our highlight brings to front this information, and we cannot see any labels on layers beneath the polygons then when it brings it to front. So we wouldn't be able to read any of these species labels that because we had said do the species labels here. So now if we put it as false and run this, when we zoom in, we can see what any of these species are. Catfish, bullhead minnow, gizzard shad, catfish, etc. So we need false if you're going to have labels that aren't also being brought to front with this highlight option as an example. Okay. We can keep adding layers, but this allows you to get the gist of we've added polygons, polylines, and circles here. So we have multiple types of data within the same map. We're going to add a lot more aesthetics. So for this section, we're going to discuss some of the aesthetics of our maps, including colors, legends, now that we know some of the basics. So here's our basic map with all the states having a black outline and gray fill. We don't have any tiles. It's just the polygons. You don't have to add tiles. You can just do the polygons if you wanted. Our data is from the Midwest 2 data set. Color, so the outline is black. Weight is 3 for those outlines. Fill color is gray, and fill opacity is half. Okay. So we just created that very basic map of the different states in the Midwest with no base tiles. This data set also contains some information on things like land and water area and region. If we look at the Midwest 2 data here, got region, division, state, area of land, area of water, things like that. We can use some of the spatial data in association with these attribute data or reference data to explore more map making. So for example, colors. We're going to look at making palettes for our data so we can add color data based on our variables. For making color palettes in leaflet, we need to consider if we have factor or categorical data or continuous data. And these are very specific leaflet color things. So color functions for continuous data include color numeric for regular continuous data, color bin for binning or creating groups of your continuous data like 100 to 200, for example, and color quantile for binning by quantiles like 25%, 50th percent, 75%, etc. And then the color function for categorical data is just color factor, coloring by some sort of factor here. These color functions require the arguments palette and domain. Palette is what colors you want to specify, and domain is what input values you are coloring. So you use our color brewer to create what palette you want. And our color brewer contains pre-made palettes, or you can name the colors using RGB vectors. This is basically the basic format. Pal, naming an object to create a palette. Color numeric, same palette equals greens, which is in the R color brewer package. Domain, it's whatever data you want. For bins, it's the same exact thing except it's color bin. All of this is the same thing, but you put the number of bins that you want. So as an example, palette 1, seeing color numeric, palette is magma, which is in the R color brewer package. And domain, we want to color based on the area of land of these states. So our domain is the Midwest data, the area of land. We say that palette. It's going to automatically create different colors based on the specified palette using the area of land. So if we add our polygons, we say the data are Midwest 2. Our color is black for the outline of our states. Weight is 3. Fill color by PAL 1 wrapped around a land. We want to fill by the area of land, but we want to use the specific color palette we just made. So we say PAL 1 wrapped around the same variable we had as the domain for this palette. So area of land, and then fill opacity half, or whatever transparency you want. So what this does, it does not automatically create a legend like TMAP does, but it does change the color by the area of land associated with each state. We could do any palette here, Viridis, for example, and do it again. And now we have a different color palette of Viridis, and it's coloring based on the area of land. All right, this one's going to be a color bin. Color bin, palette, magma, same palette. Domain, we're taking our fish data and we're going to bin by length of the fish. You do have to specify the number of bins, but you can, which would just be like 10 here. Taking our data, this one we're just going to add tiles, because why not? Then we're going to add those circles. Our data are fish locations, same data as our palette. Our color, gray 10, because the circles have the fill color as well as the outer color. Our radius, we're just going to set really high at 1,000. Our fill color is by the variable length using our palette 2 that we just made. So by palette 2 of our length data, which is what we specified up here as a domain. And for here, we have fill opacity is 100%. All right, can't see this very well, but if we zoom in, we can see it a lot better. We have these different colors. The magma data set is all vary by the length of the fish that were collected. Again, no legend is automatically created with this, unlike in ggplot or TMAP. So here we've used two different color functions for numeric data, and we can see the different colored polygons or circles, but we don't know what the colors mean because there's no legend to define them. So when we add a legend, we can see what our colors mean. So same exact code as this one, but the magma color palette. Magma, or whatever palette we had saved over. So it might be the Viridis again. All right, we're going to add a legend, which is simply piping and then saying add legend. The placement, the position, we're going to put it in the bottom right. Our palette equals whatever palette we used for our polygons. So PAL1, put PAL1 there. Our values for that would be Midwest, A land, because that's what we used in our making our palette. Our title of our legend is land area, and make opacity the same as fill opacity here, so whatever that is, just so the colors look the same. So we've got land area, and we have a numeric gradual gradation of many billions or whatever, 150 billion to 200 billion. And now we know what those colors correspond to because we have a legend that's thrown in there as well. All right. I'm going to exit out of those. We do this with these circle markers. We add the same thing for the legend. So this is for our fish leaflet, where we're varying the color by fish length. We're going to add a legend. Pipe, add legend, put it in the bottom right. Palette is palette 2 because that's what we saved for the fish length. Our values come from the fish locations data set in the length column. Our title is fish length in millimeters, and our opacity is 1 because that's the same as whatever we filled by. What this does is it made this one was based on length bins, and we had specified do 10 length bins. So each color here is represented by, or each length bin. So black is 0 to 100, this pinky is 400 to 500, etc. R automatically remembers what those length bins were from that color palette, and it will automatically put those length bins that were created by the color palette using the color bins function in the legend. So you don't have to specify the bins here. It's going to automatically do it. So leaflet legends automatically handle the differences in how the palettes were created. It'll specify the bins, or it'll specify some sort of continuous or factor categories. So if we created a palette from bins or quantiles, the legend and data colors will reflect that automatically when we call the correct palette name. We can also, so that was like seen in this one where we had the bins that it specified. You can also add a scale bar and graticules for the maps, just so we did T-map. There's really no need to add a compass because it uses Google base maps and will always be oriented with north at the top. But you can add a compass if you want. So this is the same fish locations, whoops, base map. Here we're going to add scale bar into the top right. This is our fish locations, varying fish length, varying color by fish length. We now have a scale bar in the top right because we said position equals top right. We can add graticules using just add graticules. So what that does is add the grid lines. So now you have grid lines on your map. I don't know what the default spacing is, but that's something that could be looked into with looking at the help function for this. You do interval, the spacing in map units between horizontal and vertical lines is the interval. So you can alter what that interval is, like if it's 10 degrees or whatever. So look at this if you want to change any of those or not. All right, layering in T-map. You can create different layers that the person interacting with the map can hide or show, which I think is awesome, which means that you can have multiple legends and multiple data types on the same map. What you do is you create layers using group arguments. We're going to show, or we're going to talk about, to go back to the multi-layered map we had made before and add colors to it like we did with the two previous palette functions and add legends. So for this, we're having a new palette called PAL3, color factor. Palette equals set1, which is inherent in R. We're saying domain, do the streams data set and color it by state of our streams. So our streams 2 was the Mississippi River. We're going to color sections of that Mississippi River by whatever state it was in. All right, we're going back to our multi-layered figure, our multi-layered map. Leaflet, we're adding the polygons from Midwest 2 with a black outline and a fill with gray. And we're labeling by name and highlighting it. So again, what that part looked like is our highlighting with those labels of our state outlines. Here we're going to add polylines from stream 2 data, our Mississippi River. We're saying the color. We hadn't done a factor color before, but our color is based on PAL3 that we just made, based on state, because it's what we specified for that. We want our label to be the name of the river or streams, and our group, we are naming this group equals streams in quotation marks. We're going to see what the groups do. This is to add those layers. All right, now we have the colors that vary by state border here. If it borders two states, it's a different color than if it only borders one state at that time. All right. Now we're going to add circles. Our fish data, the fill color was by length using that palette we created with the bins. And our label is going to be species, and we're going to name this as group equals fish. So we have two groups. We have streams and fish. And if we keep zooming in, this is on the Illinois River, so it's different. We've got our different fish here, our different fish here, and then our color for the Mississippi River. So what we're going to do is add a legend that tells us what the states are for the stream, as well as what the fish lengths are for those fish. So we're going to say add legend, put this in the top right, use palette 3. So this is for the polyline streams. Our values are going to be stream to state because that's what we had the color change by is the state. Our title for this legend is state. Fill opacity is half because that's what we would have put for the fill if we had to. And we're saying our groups is the same thing as what we labeled the groups for that layer in our map. We're going to add a second legend. So pipe, add legend. Put this one in the bottom left. The palette is pal2. We're doing this for the add circles of fish locations. That was pal2. Our values are fish locations length. Our title, fish length millimeters. Opacity is half. Or we could put that as 1 actually to make it match the fill opacity there. Our group is fish. This must be the same name as the data you are using. They have to be grouped the same. Okay. We have state and all the different state combinations here. Many, because there are many states bordering them, and if there's multiple states, they give it a whole different designation. Then there's fish length. So we have two legends for our different groups. All we had to do was specify it with the group function. Group equals fish and make sure it corresponds to our group that we use for our data. Group is fish. Group is streams. Group streams. They correspond to one another. That's how we have multiple legends on here. The legends don't move as we move in and out. What would be helpful is if we could hide these legends or toggle data on and off, and we can actually do that. We can click the layers on and off. All of this to this point is the same exact code copy and pasted from this map. We're just adding this function called add layers control. We're going to put this control in the top left. We're saying overlay groups. So these are the groups that we have that we want to toggle on and off. And remember, our groups are called streams and fish. Streams, fish, they correspond to the groups we had for our data as well as our legends. Options equal layers control options, collapse equals true. So these will be collapsed. We'll see what that means. Now we have this little layer here. It is collapsed, so we don't all see all of them. We have to hover over the little layer feature, and we can click streams off, and the stream goes away. So we just have the fish, and we just have the state outlines. We can click both of them off, so it's just the state outlines. We could put streams on, fish on, etc. I find this awesome. They can look at different map features and their own legends and have them mapped together. If we put collapse equals false for this add layers control, it just shows that control right there automatically. It doesn't make the little layer symbol there. Either one is valid, but if you have like 10 layers on a map, you probably want to collapse that. All right. Finally, we're going to look at saving a leaflet map. So now that we've created a really cool interactive map, We want to share it with colleagues. So how do we save this type of map? Usually save it as an HTML file. So we first have to save our map. So we're just going to save the one. This is copy and pasted from our last layering here. We're saving it as leaflet map as that object. And then it's just using the HTML widgets library. If that's not loaded, load it now. We're using the function save widget. Specify your map name of the object you saved it as well as the file path and the name of your file you're saving, plus whatever extension. And here, .html is good. Self-contained equals true is basically just saying make it all in one file instead of multiple files for like different layers. So I'll show you what this looks like. So when I pull this map up, it's now in an HTML file. So when you pull it up, it'll open up in a browser and it's the map. It's interactive, can click on things. This is much better than looking at it in the R window. You can zoom in and out, look at the names of the states, the names of the river, the names of these different fish. You can toggle the fish off, the streams off, alter those legends, etc. So this is a really nice way to share these types of maps with colleagues if you're into that. Okay, so that is a way to make interactive maps using multiple layers, multiple groups. This ends the final module for this workshop series. And as a reminder of all the modules together that we went through, it included importing and exporting spatial data, as well as projecting, reprojecting, and cropping those data, spatial data wrangling, static maps using tmap, and this is the interactive map one using leaflet. So if you went through all of these modules, you should be able to put all of the elements together to do introductory map making in R. And this should lay a foundation for learning more complex things and how to make your maps specific to the aesthetics you want. Just like with the other modules, if you are interested in testing your knowledge and skills with other data sets, use the exercise 4 interactive maps to learn how to do more interactive map making and practice this. I did want to finally show what this type of feature looks like in an R Markdown file that is saved as an HTML. If you are interested in just following along within this document rather than the R Markdown document, you can see the interactive maps a lot better and still interact with them in the HTML portion of this. So hopefully this looks a little bit more fun than just staring at the R Markdown document file in here that has issues sometimes with the viewing port with leaflet specifically. All right, thanks for tuning in.